Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos.
Right, let's have a look at this one. So this was the 2014 paper. So a stand is being used to prop up a portable solar panel. It consists of a support that is hinged to the panel at the top and an adjustable strap joining the panel to the support near the bottom. By adjusting the length of the strap, the angle between the panel and the ground can be changed. The dimensions are as follows. AB is 30. Okay, I'm going to write these in as I have them. So AB is 30. AD is equal to CB is equal to 5. AD, which is equal to BC, or CB, which is equal to 5, which must mean that one in the middle then is 20. CF is 22. Okay, and EF, a bit down the bottom, is 4, which must mean he's 18 there in the middle. Okay, find the length of the strap DE such that the angle alpha between the panel and the ground here is 60 degrees. Okay, so find the length of the strap DE, okay? So always when you see a trig question, okay, or triangles, think trig. It's either geometry or trig, okay? So think trig, and you're always trying to form triangles, okay? So I see something here. I see the strap DE. Well, that's not a triangle. So the strap DE is part of a triangle here. Yet the angle that they're talking about in the question is outside of that triangle. So I asked myself, is there another triangle? And it turns out that yes, there is. Okay, so I see two triangles. I see a big one, okay, which is A, F, and C. Okay, so let me put in dimensions of him. A to C then are 25. C to F is 22. Of course, I don't know the bottom, but there lies my 60 degrees. Okay, and then I have a smaller triangle, which has the strap. So D and E, so that's the X that I need to find. And let's fill in the the dimensions of him. DC then is 20. This is 18. And I don't know anything else. Okay. Both of them are non-right angles. Okay, so I'm sine ruling and I'm cosine ruling. Okay, so just like we did before, either the sine rule or the cosine rule. The cosine rule is when we have loads of angles. The sine rule is when I have a split between angles and sides. Okay, so I'm looking at this one and I see 3 sides. So I'm thinking I'll need a cosine rule on him. Okay, but to use the cosine rule, I need an angle. Right? So that's where my brain is at on this one. And of course, this is the major triangle because it contains DE, which is the length of the strap that I need to find. So, right, what's the link between the two triangles then? Well, it's this common angle C. So I could use this triangle here to find this angle C up the top, fill in the angle C here, and now I'm set up for my cosine rule. Okay, so how do I find this angle up here, C? Okay, well, cosine rule, no, because if I'm going to find an angle using the cosine rule, I need to know the other 3 sides, and I don't know AF down here on the bottom, which means that it must be the sine rule. So the sine rule and the cosine rule gives you the same answer. It's just you'll only ever have enough information to use one of them. So therefore, it must be the sine rule. Okay, and sine rule works in pairs. Sine rule relates the side to the angle across from it. A to angle A, B to angle B, C to angle C. Okay, that is the nature of the sine rule. Okay, so therefore when I'm doing the sine rule, you will see me putting these arrows in, which I'm literally linking the angles with the sides across from them. Okay, so that is an angle side pair. So I'm going to say 25 over sine 60. Okay, and I need to let that equal to another side angle pair. We don't ever use the three of them. We tend to use any two out of the three. Okay, so I need another angle side pair. Well, I only have one other piece of information, which is another side. And the side across from it is that angle down there. Okay, so if I use the sine rule, I do not find this angle C, I find this angle down here at F. But that's all I can do. Okay, so it's 25 over the sine of the angle CFA if you want, okay? Or you can call it sine F. We might just call it sine F just for shorthand. Okay, and cross multiply here away so that you get 25 sine F being equal to 25 sine 60. And let's divide across by 25 then. I have done something wrong.
Eva, is CF not equal to 22 centimeters instead of 25?
Yes, because they were just about to cancel for me. I was like, I don't remember them cancelling before. Thank you. So this one here, this 22, isn't it? 22 over sine 60. Yeah, now we'll go down to 25 sine 60. He needs to be a 22. Okay, we're away. Okay, so sine F equals. Put that into your calculator, okay? And again, make sure you're in degree mode, especially when you're on trig, because you could be hopping between radians and degrees. So I've got 0.9841 for that. And if I sine inverse him, then I will get the angle down there at F. So 79.78 degrees is what I got down there for him. And let's fill him in. I was going to round him, but I didn't. Okay, we'll leave him for now. Okay, no big deal because we know angles in a triangle add up to 180. So if I add on the 60 degrees that's here and subtract from 180, won't I then find the angle that's up there at C? Okay, so what I'm doing is 79.78 plus the 60 is 139.78. And let's subtract him away from 180. And I've got 40.22 degrees. Okay, so 40.22 degrees. And of course, that's the angle that is also down in the small one. Okay, so I hope that makes sense. And it's for this very reason that I put in the arrows when I'm doing the sine rule, to make sure that I know which angle I'm solving for. Okay, visually, I can see which angle I'm solving for, and then, because you can see, it's very easy to get the third angle. It's not like they have to set up the question that the sine rule gives you the angle that you want. Okay, so use visual cues as well. Okay, let me add in another page so we're not scrimping. I'm going to redraw that blue triangle down the bottom, small one. Let's fill in our dimensions again. So we are doing 20, 18. I hope I have them right this time. What is this one? 40.22 degrees. And this is the side that we need, which was DE, the strap. Okay. And it's a cosine rule. It's a cosine rule because I'm all about sides and a single angle. Okay. Couldn't use the sine rule in this one because although I have a side angle pair there, I do not have an angle to match either the 20 or the 18. So the sine rule isn't an option here. Okay, so it has to be the cosine rule. Okay, and this is what makes this a beautiful exam question, because it examines the sine rule, it then examines the cosine rule. So it's checking all of your skills of geometry. So remember what we did in the last question. You have to be careful. Let me write out the cosine rule. You have to be careful that the angle you take in your question has the side opposite it here, okay? So we're lucky enough, this is the angle in our question, this is the side that we need, which makes this a relatively easy question because everything on the right-hand side of this formula will be numbers that you can then put into the calculator all in, I can't read my own writing, 22 degrees. So all that right-hand side you can put into your calculator all in one fell swoop. Because it's just numbers. So minus 2 times 20 times 18 times cos 40.22. Forgot the cos. And I got 174.229 for that. And of course, square root that to give you x, the length of the side, 13.19959. I can't remember what it says. Find the length of the strap. It didn't say, so I tend to do 2 places of decimals. So 13.20 centimeters would be the length of that strap that I would report on. Okay. So I hope that makes sense. A great question for understanding the sine rule, the cosine rule, the differences between them, when you use them, when you don't, okay? But do remember that both will give you the same answer. It's just you don't have enough information typically for one of them. So the following part then, find the maximum value of alpha correct to the nearest degree. So the maximum value of alpha. Okay, so alpha being the angle. So I'm back here now on the big triangle. So let's draw him. So we had a 25, we had a 22, and we had an alpha. And of course, we worked out the other one. Okay, not to worry. Okay, so the biggest value of alpha will be if you move this side here straight. Okay, so if you can visualize this coming down straight, it's going to push this side up, okay? So again, imagine this side coming in and it has the net effect because if he moves in, okay, he gets straighter, so he gets taller, okay? Because something that's straighter is naturally taller, okay? And think about you standing straight and thinking about you slouched back against the wall, okay? So when you stand straight, you stand tall, okay? Now the length of this side can't change, so it's going to rise up to meet it, okay? Which is going to increase this angle here. So you always get the maximum value when the prop or the stand is at a right angle. Okay, so let me redraw this one to show the right angle that it's going to become. So he's still going to be 22. He's still going to be 25. And of course, I need to find the angle now that represents the two of them. Okay, so again, let's label our sides. So opposite, hypotenuse, of course heat is adjacent. Silly old Harry caught a herring trawling off America, and we're looking at opposite and hypotenuse. So it's a sine of the angle is equal to 22 over 25. Okay, or alpha is equal to the sine inverse of 22 over 25. Okay, so you can see the math's very easy. They're just trying to figure out if you understand the concept of something being up straight to the nearest degree. 62 degrees is what I make alpha then. Okay, which is quite close to the 60 that they gave us in the question, which kind of gives me a warm, fuzzy feeling that I'm not a million miles away from my, from the value that, my method is fairly right. I'd be confident in it.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.